Have you ever wondered how your body fighting off a simple cold has anything to do with protecting an entire city from a pandemic? It sounds like a massive leap, but it's really not. Today, we're going to dive into how the memory of a single, tiny cell can scale all the way up to create an invisible shield for all of society. And it all kicks off with one huge question. This right here is the question that keeps public health experts up at night. I mean, think about it. One person gets sick. How on earth do you stop that single case from becoming the spark that ignites a global fire? Well, to even begin to answer that, you need a very special kind of detective work. And that detective work starts with tracking the disease itself. You see, to stop an outbreak, you first have to understand its story. You've got to know where it's been, and way more importantly, where it's headed next. Now, there's an official name for this field. It's called epidemiology. And epidemiologists, these are the boots on the ground. They are literally mapping out the who, what, where, and when of an illness, all to figure out its cause and, of course, how to stop it in its tracks. A really crucial thing these detectives know is that not all outbreaks play by the same rules. Some are what we call a common source epidemic. Think of it like a leaky faucet. You find the source, like contaminated food, you turn it off, and the problem stops. But others are like a wildfire. They jump from person to person in a devastating chain reaction. That's a propagated epidemic, and it is a much, much bigger challenge. So that's the big problem, right? If you've got this disease wildfire jumping from one person to the next, how do you stop it from burning down the entire forest? How does a whole community build a firewall? Well, the answer is this really powerful idea. It's a concept that acts like an invisible shield for an entire community. And it's called herd immunity. And it is such a cool concept when you think about it. Herd immunity isn't actually about making every single person immune. It's about building so many immune roadblocks in a community that a virus just runs out of places to go. The chain of infection literally breaks. And that shield is what protects the most vulnerable among us, newborns, the elderly, people who can't be immunized for medical reasons. So what's the magic number? How many people need to be immune for this to work? To figure that out, scientists use this critical value called R0 or R0. This number basically tells you one simple thing. In a population with zero protection, how many other people will one sick person infect? It's the raw, unfiltered contagiousness of a disease. And this R0 number, it's a total game changer. Look at this. If a disease has an R0 of 2, you need about half the population to be immune to stop it. But for something crazy infectious like measles, which can have an R0 of 12 or even higher, you need to get over 90%. The more contagious the enemy, the stronger that community shield has to be. We've been looking at the really big picture here, entire populations, but herd immunity is built one person at a time. The real magic, the foundation for all of this, happens on a microscopic scale. So let's zoom all the way in. Okay, deep inside your body, that shield we've been talking about, it all starts with your body's first line of defense. This is the security force you were born with. Think of your immune system as having two main branches. First, you've got your innate immunity. These are your body's general security guards, always on patrol, ready for anything. Then you have your adaptive immunity. These are the elite special forces. They're called in for very specific threats, and they never, ever forget a face. So this innate system, the general guards, is literally your wall. It's your skin, the mucus in your nose, physical barriers trying to keep stuff out. But if something does get through, this system launches an immediate brute force attack. It doesn't know what the invader is, it just knows it doesn't belong. Its job is to hold the line while the real specialists get ready. Because here's where it gets amazing. While those general guards are fighting on the front lines, the elite special forces, your adaptive immune system, are in the back taking notes. They're learning. And this right here is the true superpower of our immune system, memory. I mean, just let that sink in for a second. Once your adaptive system has met an enemy, the next time it shows up, the response is so fast and so powerful that you probably won't even know you were exposed. That is the incredible power of immune memory. So what's it actually looking for? How does it recognize the bad guys? Well, it's looking for something called an antigen. And the best way to think about an antigen is like the enemy's uniform. It's a unique marker on the outside of a virus or bacteria that your body learns to spot as foreign. So this elite force works with a two-pronged attack.
First, you have B cells. Think of them like tiny weapons factories, pumping out custom-made proteins called antibodies that lock onto that enemy uniform and neutralize it. At the same time, you have T cells. These are the assassins, hunting down and destroying any of your own cells that have already been infected. And the most important part? Both of these units create veterans, memory cells, that stick around for years, ready to fight again at a moment's notice.
This whole system is amazing, right? But it leads us to one of the most important questions in the history of medicine. We know our bodies can build this incredible, long-lasting defense. But is there a way to teach it how to fight an enemy without having to go through the danger and misery of a full-blown infection first? And the answer, thankfully, is a huge yes. This is where we zoom back out. This is where we connect that one cell's memory to the safety of an entire city. We don't have to get sick to get smart. We can actually train our immune system. And that's exactly what a vaccine is. It's not really a medicine that cures you. It's more like a training manual. It introduces your immune system to the enemy's uniform, that antigen, in a totally safe way, so it can prepare all of its defenses without ever having to fight a real war. The whole process is really elegant. A vaccine gives your body a safe, harmless look at the enemy's uniform. Your immune system sees it and runs a full-scale training exercise, building up its antibody factories and training its assassin cells. But most importantly, it creates those vital memory cells. The result? You're left with a pre-trained army ready to defeat the real threat before it can even get a foothold. And this brings us right back around, full circle. A vaccine isn't just about you. Every single trained immune system becomes another brick in that community wall. Another part of that invisible shield. It stops the spread. It protects the vulnerable. It's the ultimate example of how personal protection creates a public good. So there you have it. What a journey, right? We went from the epidemiologists tracking a global pandemic, zoomed all the way down to the biology of a single memory cell, and then all the way back out again. It's just amazing how one cell's ability to remember, when multiplied across an entire community, can literally save the world. It's an incredible story of interconnectedness. But you know what? The story doesn't end here. As science just keeps rocketing forward, we're entering this whole new era of vaccinomics, using super powerful tools like genomics and AI to design even smarter vaccines. So it leaves us with a final fascinating question to think about. What will the future of immunity look like?